Alright, good morning everyone. You know, all 5 people that watch my videos. So this morning we're going to discuss the failure mode of this Philips light bulb. This light bulb is sold probably in different places under maybe different names. This one was branded and sold at Ace Hardware, but it's made by Philips. I bought a couple boxes of these about 3 years ago, and they've started failing one by one about a couple weeks apart. The reason I know how long they've lasted is that ever since we've gotten these new CL bulbs or LED bulbs, I put the date of installation on the bulb to see if they're really lasting as long as they say. Now this one claims that it would last 22 years, but it only has a 3-year warranty, and if you read the fine print, the 22 years is only if the bulb is installed in free air and used only for 3 hours a day. So, you know, it's utter crap. It's not really meant to last 3 years or 22 years. But anyways, they've all started doing the same thing. They would start flickering and then they just go out. And the first one I took apart, and I was able to get the globe off without destroying it too badly. My intention was I was actually going to try and repair it. In fact, these things are, if they weren't so hard to get into, would be easily repaired. But once I got the globe off, that was the easy part. The next problem was that this metal cap here is apparently press fit into this socket base, and this aluminum, I believe this is aluminum, is very soft. I've never seen aluminum this soft in a long time. This is just ridiculously soft stuff. And so initially I thought if I unscrewed these 2 screws I could lift off this LED array and I would be able to access the circuit board inside. Well, as you can see, it's a solid piece of metal, and I tried to pry up on it on the previous ones and just thoroughly destroyed them. They were stuck in there so tightly that, you know, any attempt to remove them without destroying them was nearly impossible. I tried heat guns, I tried all sorts of things. The other problem was there was some ominous rattling noises coming from inside the earlier ones, and when I opened them up I found that this little transformer on one had crumbled into several pieces, and on the second one had just come off from the circuit board. So when my wife noticed that this one was flickering, I immediately took it and, using a Dremel tool, I carefully cut the sides open so that I could pry it open and get this lid out, and then get this circuit board out in one piece. It was so soft. I'll put a picture in here and you can see what kind of how soft it was by all the aluminum or whatever metal this is that's covering the cutoff wheel. I've never cut into aluminum and had to do this. So once I pried this open, this then popped out, and it just simply, there's a plug here and it just plugs into this thing. I'm not exactly sure how they put this together, because the way this is held in here, it looks like they somehow managed to put this circuit board in here. There's a notch to hold it in place, and then somehow they managed to get this on here and crimp it, and then it looks like they put this piece on and crimp the aluminum in place, and then possibly coat it with this hard plastic. I'm not really sure. This thing is just designed to not be worked on. They absolutely don't want you repairing this. Whether they intentionally did that or it's just a result of the design, they certainly don't want you doing anything. So what I found, like I said on the first one, this little, let's see if I can zoom in here a little more. This little transformer was broken and it was off the circuit board. The cover to this capacitor was gone. It had crumbled into dust. On the second one, this had fallen off. The same thing, the cover to the capacitor had crumbled into dust, but the capacitor had been blown out at the base. And I think what happened is the capacitor vented. The device was probably still working, and eventually the capacitor juice ate through the pieces of metal that get soldered into the circuit board. I'm not going to reverse engineer this or anything. I'm almost certain I could fix this just by replacing these two capacitors. They're 250 volt, 4.7 microfarad and a 2.2 microfarad. And I was going to try and fix them, but the closest I had was to the 4.7 was a capacitor that wouldn't fit on this board, and the same with the 2.2, and both of them were the axial type of capacitors, so it's not really any point in doing it. I can't get it back together, and as this thing sits, it actually still works, but it'll start to get hot, and then it starts to blink and it goes out. I think the actual cause of the failure on this is heat. These capacitors are rated at 105 degrees Celsius, and I'd have to look up what that is in Fahrenheit, but I think it's around 220. And when I measured these light bulbs with a thermal infrared thermometer, I was reading almost 200 volts, 200 degrees Fahrenheit on the outside of this, which means that inside it was probably pretty close to, if not exceeding, the ratings of these capacitors. And the reason for that is that these were installed in a ceiling fan in globes that point down at an angle, and so they have no way to vent the heat. These were invented before, or the ceiling fan was created before they had such lights like this. And I looked to see if anybody sells globes that have vent holes in them, and they don't, and have a plan to possibly fix that issue by drilling some holes in the bases, and that might allow a little bit of heat to escape, get a little bit of airflow going over these. But yeah, these don't like heat, just like CFL bulbs. They really expect that they're going to be sitting in free air and not inside of a globe or enclosed in any way. So that's basically it. Thanks for watching.